In last video, we have seen about the fundamental quantities and fundamental units. In addition to fundamental quantities and fundamental units, we have seen also the supplementary units. A fundamental quantity means the physical quantity which do not depend on any other quantity for their measurements are called as fundamental quantities, and the unit used to measure the fundamental quantities are known as fundamental units. Now today we see about another quantities, that quantities are known as derived quantities, and units used to measure the derived quantities are known as derived units. Now first we see the definition of derived quantities. The physical quantity quantities other than fundamental quantities other than fundamental quantities which depend on one or more fundamental quantities for their measurements are known as derived quantities. See definition again. The physical quantities other than fundamental quantities which depend on one or more fundamental quantities for their measurements are known as derived quantities, and unit used to measure derived quantities in terms of fundamental units are called derived units. Again, see the definition of derived quantities and derived units means the physical quantities other than fundamental quantities which depend on one or more fundamental quantities for their measurements are known as derived quantities, and unit used to measure derived quantities in terms of fundamental units are called derived units. So in physics we come across number of derived quantities. For example, area, volume, density, force, acceleration, work, pressure, momentum, etc. So we can obtain its derived units easily by using the formula of these derived quantities. So first derived quantity is area. You know the formula for area, that is length into breadth. By using the SI unit of length and SI unit of breadth, we get SI unit of area like that. SI unit of length, it is known as meter. Breadth is also measured in meter. So we get SI unit of area as square meter. Symbolically, it is represented as n square. So this is SI unit of area, that is square meter. Symbolically n square. Now another physical quantity is volume. You know the formula for volume, that is volume equal to length into breadth into height. By taking the SI unit of length, breadth and height, we get SI unit of length is meter, SI unit of breadth is meter, SI unit of height is meter. So we get cubic meter. Symbolically, it is represented as m raised to 3, that is cubic meter. So this is the SI unit of volume. Another example for derived quantity is speed. So speed means it is distance divided by time. SI unit of distance, it is meter, and SI unit of time is second. So we get SI unit of speed, that is meter per second, symbolically represented as m per s. It is also denoted as m s raised to minus 1. So this is SI unit of speed. Similarly, we can obtain the SI unit of velocity. So velocity means it is rate of change of displacement with respect to time. So SI unit of displacement is also meter. SI unit of time is also second. So we get similar unit of velocity, that is meter per second or m s raised to minus 1. Another physical quantity is acceleration. So acceleration means rate of change of velocity. So acceleration means velocity, change in velocity divided by time. by knowing the velocity unit, that is meter per second, and time unit second, we get SI unit of acceleration is meter per second square, and it is symbolically represented as m per s square or m s raised to minus 2. So this is the SI unit of acceleration. Another derived quantity is force. So force means formula product of mass and acceleration. By knowing the SI unit of mass, that is kilogram, and SI unit of acceleration is meter per second square, we get SI unit symbolically kilogram into meter per second square. So it has the special name. The SI unit of force, it is Newton. SI unit of force is Newton. Its symbol is capital N. Then another derived quantity is impulse. So impulse, it is the product of force and time. By knowing the SI unit of force as Newton and SI unit of time is second, we get SI unit of impulse is Newton second, symbolically Ns. Then another derived quantity is work, and its formula is work equal to force into displacement. By knowing the SI unit of force, that is Newton, and SI unit of displacement is meter, means symbolically Newton, meter, and it has the special name, that is joule. And its symbol is capital Z. So SI unit of work is joule, symbol capital Z. Then another derived quantity is energy. Its SI unit is also joule, symbolically capital Z. Then another physical quantity is power. So power formula is rate of change of work with time. So power equal to work divided by time. SI unit of work is joule. SI unit of time is second. So symbolically we get joule per second, and it has the special name, that is watt, capital W is its symbol. So power means work divided by time. SI unit of work is joule. SI unit of time is second. So joule per second is the SI unit of power. Symbolically, capital J per S, and it has the special name, that is watt. Symbol is capital W. Then another derived quantity is pressure. So pressure means force per unit area. By knowing the SI unit of force, that is Newton, and SI unit of area, that is square meter. Symbolically, it is represented as Newton m raised to -2, and it has the special name, that is Pascal. So SI unit of pressure is Pascal. Another derived quantities is electric potential. Its SI unit is volt. Another derived quantity is the charge. SI unit of charge is coulomb. Symbol is capital C. Another derived quantity is electric resistance. Its SI unit is called as ohm. Symbol is omega. Then another derived quantity is like velocity gradient, and we get velocity gradient means velocity gradient means velocity upon distance. SI unit of velocity is meter per second, and SI unit of distance is meter. Simplifying, we get SI unit of velocity gradient is s raised to -1. Then another derived quantity is the momentum, and momentum, it is the product of mass and velocity. Symbolically, momentum P equal to mv. By knowing the SI unit of mass, that is kilogram, and SI unit of velocity is meter per second. So SI unit of momentum is kilogram meter per second. Symbolically, kg meter per second. So this is about the derived quantities and derived SI units. So derived quantities means the physical quantities other than the fundamental quantities which depend on one or more fundamental quantities for their measurements are known as derived quantities, and unit used to measure the derived quantities are called derived units. and the derived units, they are expressed in terms of fundamental units. Now today's homework: what is derived quantities and derived units? State derived quantities with SI units.